Take a bite of a Magnum. Listen carefully. That deep crack isn't normal, because most chocolate-coated ice creams use thin shells that break instantly. But Magnum, their chocolate is noticeably thicker, richer, heavier.
And here's what makes it strange. In an industry obsessed with cutting costs, why would a company intentionally use more chocolate than everyone else?
Wouldn't that hurt profits, slow production, make the bars harder to manufacture? Yet somehow, no other ice cream has been able to replicate that same thickness, that same snap, that same premium bite.
So what does Magnum know that the rest of the industry doesn't?
Is it the chocolate formula? A secret temperature? Custom-built machinery? Or a manufacturing process so precise that most factories simply can't execute it? To answer that, we can't start with the chocolate. We have to go all the way back to fresh milk, to fat ratios engineered in labs, to freezing systems powerful enough to stabilize liquid in minutes, and finally, to one of the most technically demanding coating processes in modern food manufacturing. Today, we're stepping inside the complete journey of Magnum to discover how a brand turned thickness into luxury and engineered an ice cream bar no competitor has truly matched. So stay with me, because once you see what it actually takes to create that signature crack, you may never look at ordinary ice cream the same way again. Every Magnum begins its journey with milk from select dairy farms. This isn't just milk from any cow. It is carefully monitored for fat content, protein levels, and freshness. Milk is collected within hours of milking, ensuring minimal bacterial growth. Fat content is precise. Too low, and the ice cream lacks creaminess. Too high, and it becomes difficult to freeze uniformly. Once collected, the milk undergoes pasteurization, heated to high temperature briefly to kill harmful bacteria without affecting flavor. Cream then is added to adjust fat percentage for a richer, more indulgent mouthful. Sugar and other ingredients like stabilizers and emulsifiers are added with meticulous precision.
But fresh milk alone isn't enough to give Magnum that luxurious creaminess. The real transformation begins in the mixing tanks.
Milk and cream are pumped through high-pressure homogenizers, breaking fat molecules into microscopic droplets. This ensures that every bite is silky smooth, no graininess, no separation. Sugar dissolves completely, stabilizers activate, and emulsifiers bind water and fat perfectly. The mixture is then cooled and allowed to rest for several hours. This is called aging. During aging, fat crystals start forming. Proteins stabilize. The viscosity thickens. Without this rest, the ice cream would feel flat or icy.
Magnum doesn't rush this. It's essential for the signature smooth texture.
The base may look simple, but skipping this aging process would ruin every bar. So what happens next? The freezing process, where science and art collide.
The aged base enters continuous freezers, spinning rapidly to incorporate air, a process called overrun. Too much air and ice cream becomes fluffy and cheap. Too little and it becomes dense and heavy. Magnum targets a precise air percentage, balancing density and creaminess for that premium feel. The mixture becomes soft-serve consistency, partially frozen but ready for molding.
It looks simple, but this step sets the stage for the ice cream to survive a thick chocolate coating without cracking, something most brands can't do.
Soft ice cream is injected into pre-cooled molds shaped perfectly for a stick bar. Wooden sticks are inserted with millimeter precision. Molds pass through blast freezers at -40 degrees Celsius, hardening the ice cream rapidly. Why blast freezing? Slow freezing forms large ice crystals, rough texture. Fast freezing maintains smoothness and allows the ice cream to hold a thick chocolate shell later.
The ice cream is now solid churning, but it still isn't a Magnum. The chocolate coating is the part that defines it as a luxury bar.
Magnum's chocolate is formulated specifically for thickness, higher cocoa butter for smooth flow, correct viscosity for snap and adhesion. Bars pass under a continuous chocolate curtain, fully coating each bar. Temperature, viscosity, and timing are carefully controlled. Too warm, chocolate slides off. Too cold, cracks appear. Bars immediately enter rapid freezing tunnels, hardening the chocolate shell in seconds. This thickness is what sets Magnum apart. It delivers the satisfying crack, an indulgent bite.
This thick chocolate is the most challenging part to manufacture consistently a Lordy, but it's also why no competitor can replicate the experience.
Certain Magnum bars include hidden layers, like caramel or raspberry. Ice cream is injected first, then sauce, then ice cream again. Each layer is rapidly frozen to prevent collapse or blending. This multi-layer process adds indulgence and complexity without compromising structural integrity.
Now the bar has flavor complexity, but how do they keep it intact from the factory to your freezer?
After the chocolate has hardened, the ice cream bars are ready for the final stages in the factory, but perfection is not guaranteed yet. Magnum takes packaging very seriously, because this step is not just about wrapping, it's about preserving the bar exactly as it was designed to feel and taste. Here's what happens. 1. Bars are aligned on high-speed conveyors. Every single bar is checked for proper shape and symmetry. Even a slight tilt or an uneven chocolate layer could affect the snapping experience. 2. Automated robotic arms wrap each bar in its foil and sleeve. The wrapping isn't just for hygiene, it is part of the structural support that prevents the chocolate from cracking prematurely. 3. Quality scanners continuously inspect each bar. These scanners detect misaligned sticks, air bubbles under the chocolate, small cracks or surface defects, weight consistency to ensure every bar has the correct chocolate thickness. 4. Defective bars are immediately removed. This is a critical step because Magnum doesn't compromise. Even one imperfect bar is rejected. 5. Bars are placed into insulated boxes for shipment. The boxes are carefully arranged to minimize movement. The factory calculates vibration, pressure, and stacking order to avoid any damage to the chocolate or ice cream.
Even after this seemingly final step, the journey isn't over, Sled, because no matter how perfect the factory makes it,
the bar must survive the world outside. Packaging alone cannot guarantee the perfect Magnum experience. The real challenge is transporting hundreds of thousands of bars over long distances without ever losing quality. Frozen trucks leave the factory at precise temperatures, -18 degrees Celsius or lower. This prevents even microscopic melting, which could ruin the smooth texture of the ice cream or cause the chocolate to lose its snap. Each shipment is tracked in real time. Sensors inside the truck constantly monitor temperature, humidity, and vibration. Any deviation triggers an alert, because even a slight rise in temperature could create large ice crystals in the ice cream. Loading and unloading are handled carefully. Workers are trained to minimize impact, prevent jostling, and maintain perfect alignment inside boxes. Distribution is optimized by distance and storage capability. Magnum bars are rarely left sitting in warehouses for long periods. The chain is designed to move fast, stay cold, and maintain integrity. Even retail freezers are monitored. Magnum works with stores to ensure that the ice cream remains frozen properly until the moment the customer picks it up.
Now ask yourself, if every step so far is this precise, why would Magnum go to the trouble of making chocolate thicker than anyone else?
In an industry obsessed with cutting costs, why would a company intentionally use more chocolate than everyone else? Wouldn't it slow production, make bars harder to manufacture, and hurt profits? Here's the answer. Magnum intentionally uses thicker chocolate because it defines the luxury experience. But creating thick chocolate consistently on a mass scale is not easy. It requires precision engineering at every step. Custom chocolate formulation. The cocoa butter ratio is carefully tuned so that the chocolate flows smoothly during coating but hardens quickly. Temperature synchronization. Both chocolate and ice cream must be maintained at precise temperatures. Too cold and the chocolate cracks. Too warm and it slides off. High-speed, precise coating machinery. The machines are designed to fully coat every bar without compromising the ice cream inside. Rapid freezing after coating. The chocolate hardens almost instantly to maintain thickness, ensuring that snap you hear when you bite. Continuous quality control. Thickness, alignment, surface smoothness, and weight are measured in milliseconds. Bars failing to meet standards are rejected. The result is a bar that delivers a sensory experience no competitor has matched. That deep, satisfying crack is not an accident. It is the result of deliberate engineering from milk to chocolate to freezer and beyond.
Every single bar has been crafted to guarantee the snap, the bite, and the luxurious feel.
So the next time you pick up a Magnum, remember, you're holding the result of meticulous food science from farm to freezer. Every chocolate coating, every ice cream base, every stick insertion has been engineered to deliver that perfect bite. The thickness isn't just a choice, it's a commitment to luxury, quality, and consistency. Magnum isn't just ice cream, it's a multi-layered experience, a combination of ingredients, engineering, and artistry that no other bar in the world has matched.
If you enjoyed this deep dive into the hidden engineering of everyday luxury, don't forget to subscribe and hit the bell icon.
Because the next product we explore will make you see the things you take for granted in a completely different light. Stay curious, and the next time you bite into something you love, think about all the invisible engineering behind it. Because luxury, perfection, and that unmistakable crack, they don't happen by accident.